Musk deployed a strict operational framework to force extreme efficiency and pull both companies back from the brink. Elon Musk oversees the world's most valuable automaker, a private spaceflight monopoly, and a global satellite network, pushing his net worth past $1 trillion. 20 years ago, the aerospace and automotive sectors were considered impenetrable. They were stagnant monopolies defined by century-old brands and government agencies. Musk transitioned from building software and digital payment systems to tackling the most capital-intensive physical manufacturing industries on Earth. He breached these barriers by deploying a brutal, engineering-centric operational code that ignored traditional business school strategy. That code starts with a mental filter known as first principles thinking, a method for looking past the assumptions that define established industries. This approach strips a problem down to its core physical truths and raw materials. You ignore how a product has been built in the past and calculate what is possible from basic physical limits. Knowing the physical limits of a rocket or a battery only provides the theoretical vision. Turning that vision into hardware requires a functional operational machine. First principles reveal the exact target. His relentless operational algorithm dictates the steps to reach it. In 1999, Musk netted $22 million when his first software company, Zip2, was acquired by Compaq for over $300 million. He immediately reinvested those funds into X.com, the online banking platform that merged to form the digital payments giant PayPal. This era established the hallmarks of his management style: extreme 80-hour work weeks, a rejection of corporate jargon, and a focus on raw product utility. When eBay acquired PayPal in 2002, Musk walked away with a software fortune of $180 million. Instead of retiring, he used that capital to target the physical world's highest barriers to entry. Musk took the risk of personally funding both a private rocket company and an electric vehicle startup simultaneously. At SpaceX, he calculated the raw material cost of aerospace components, finding that he could build hardware in-house for a fraction of the price charged by legacy contractors. By 2008, both ventures were failing. SpaceX suffered 3 back-to-back failed launches. Tesla was burning through its remaining cash, and bankruptcy loomed within days. Faced with total ruin, Musk deployed a strict operational framework to force extreme efficiency and pull both companies back from the brink. He uses a fixed, rigid filter called the 5-step algorithm to resolve engineering bottlenecks. Step 1. Question every requirement. Musk demands to know why a rule exists based on physics, refusing to accept that it's always been done this way. Step 2. Delete what you can. If the team isn't eventually adding back 10% of what they cut, he considers the cutting process too conservative. Step 3. Simplify what remains. He views optimizing a part that shouldn't exist in the first place as a fatal engineering error. Only then can you reach Step 4. Accelerate cycle times. Automation comes last, Step 5, ensuring that only a fully optimized process is locked in. This algorithm produced immediate results. In late 2008, SpaceX reached orbit to secure a NASA contract, and Tesla managed to ship the Roadster. The algorithm turned abstract physical theories into concrete survival mechanisms, saving the companies from collapse. These results have compounded as the operational code was applied at scale over the next 2 decades. SpaceX made reusable orbital rockets the standard practice for global launches, ending the era of single-use hardware. Tesla scaled its production until the Model Y became the best-selling vehicle on the planet. This manufacturing speed allowed for the rapid deployment of Starlink, creating a global communication platform from orbit. This vertically integrated manufacturing engine replaced the fragmented subcontracting models of the previous century with a single high-volume production machine. A $1 trillion valuation followed the total overhaul of operational culture, prioritizing physical engineering over traditional market strategy. True disruption requires the audacity to break a problem down to its physical limits and ruthlessly engineer a way through the constraints. Mastering this engineering logic transformed a software developer into the primary builder of the systems powering modern transportation and aerospace.